Welcome to today's video session. In today's video, we're going to discuss about glycolysis, which is also called as EMP pathway. EMP stands for Emdon, Mayrhof, and Parnas pathway. These were the three pioneer biochemists who discovered this glycolysis cycle. In fact, they were not. This glycolysis, if you break the word glyco and lysis, glyco means glycogen and lysis means to break down. So they studied on animal muscle cells or muscle tissues and yeast cells. They were discovered on the basis of glycogen breakdown or glycogen degradation, which holds good for glycolysis or the sugar breakdown also. The same mechanism are involved. So hence the glycolysis was the name was not renamed later, it was not changed, it remained as glycolysis. But you have to know that glycolysis initially they discovered for the breakdown of glycogen in the muscle cells and yeast cells. And before entering into this topic, this glycolysis is the first part of plant respiration or animal respiration. It all good for both things. So this is the first part or the introductory part for respiration, where the carbohydrates are getting converted into pyruvic acid. So this introduction and all is been discovered, has been described in my first video, introduction to respiration of plants. For those who didn't watch those video, please watch that video, then you watch this, so that you will have a better understanding and you can remember things, you can remember the concepts very clearly. Without knowing the introduction or without knowing the basics, if you just dive into this, you feel this as complex. So I personally prefer you go and suggest you to watch that video, then you watch this video. So let us go to this video. So this glycolysis or EMP pathway, it is also called as cytoplasmic respiration. As all the reactions, it occurs in cytoplasm. Cytoplasm is nothing but the cytosol or the fluid matrix of the cell, where all the cell organelles are present. Since it occurs in cytoplasm of the cell, it is also called as cytoplasmic respiration. And it is also called as common respiratory pathway. It is common, this step holds good for all types of respiration: aerobic respiration, anaerobic respiration, fermentation. For all the respiration, this is the common pathway. Hence, it is called as common respiratory pathway, and it is independent of oxygen. Oxygen is not required for this pathway. So this is all about glycolysis. You have to remember. And one more thing, like you have to remember of this glycolysis is, in glycolysis, if you see the glucose, one molecule of glucose is converted into two molecules of pyruvic acid. That is a single step reaction. One molecule of glucose is converted into two molecules of pyruvic acid with the liberation of ions, hydrogen ions, and liberation of electrons and energy rich currency molecules. So before going to this, what is this? This is the conversion of glucose to pyruvic acid. I said you, glucose is nothing but carbohydrates. So all carbohydrates, let it be maltose, sucrose, starch or galactose, fructose, ribulose, let it be exo sugars or pentose sugars or oligosaccharides or disaccharides or monosaccharides, whatever may be the carbohydrates, the first step is all that carbohydrates will be converted to glucose, which is a hexose sugar. Hexose means 6 carbon molecules are present. So whatever may be the carbohydrate source, the first step is they are converted into glucose with their own unique enzymes and their own pathway. They have their own pathway, they have their own enzyme. First they are converted into glucose. What if it is a protein? In the proteins, the first thing they are converted to amino acids, then they also follow the same pathway. In case of glycerol and fat degradation also follows the glycolysis pathway. So what happens over here is, first thing is glucose, which is a 6 carbon molecule. As I said, it is an hexose. The glucose is converted to glucose 6 phosphate. So if you see the, you have to remember, it is very easy if you just remember stepwise, and how to remember the enzymes also. I will show you the trick over here. So the glucose is getting converted into glucose 6 phosphate. So glucose is a hexose sugar. And wherever this ATP ADP conversion occurs, you will have an enzyme called as kinase, which helps in photophosphorylation or oxidative phosphorylation of ATP and ADP. Wherever ATP ADP comes, you can blindly put kinase. And since it is the involvement of hexose sugar, the enzyme used over here is hexokinase. So here the glucose is getting converted into glucose 6 phosphate. So listen carefully to my words, even if these are not visible properly. Remember, listen to my words and note it down in your book. So glucose gets converted into glucose 6 phosphate. One phosphate molecule is added. From where did that 1-phosphate molecule come? From ATP. ATP in the sense adenosine triphosphate. 3 phosphate molecules are there. 1 phosphate is taken from ATP molecule, so triphosphate becomes diphosphate. So glucose with the reaction of ATP in the presence of hexokinase enzyme, it becomes glucose 6-phosphate, and ATP gets converted into adenosine diphosphate, and magnesium is needed as a cofactor. So the magnesium is an ion that is required as cofactor for the activation of this enzyme. This is the first step. I hope the first step is very clear. So glucose 6 carbon compound is converting to glucose 6-phosphate. Glucose 6-phosphate gets converted into fructose 6-phosphate. Glucose and fructose both are structural isomers. That means they have same molecular formula but different structural formula. Isomers, they are isomers. So the enzyme isomerase will come. Since it is phosphate molecules are involved and it is an exose sugar. Glucose also exose, fructose also exose. So the enzyme is phosphohexose isomerase. Phosphohexoisomerase enzyme. With the help of that enzyme, glucose 6-phosphate is getting converted into its isomer form, fructose 6-phosphate. This is the second step. Now what happens is additional phosphate group is added. Similarly, how one phosphate group was added, here also another phosphate group is added. So same, phosphofructokinase. Since it is a substrate molecule is fructose and it is an phosphate group is attached, we call it as phosphofructoisomerase. Phosphofructokinase. Since the ATP and ADP is involved over here, it is phosphofructokinase. So fructose 6-phosphate becomes fructose 1,6 diphosphate. The di means 2. So already there was 1 phosphate in the 6th position. The 6, 1,6, all this, it means the position where the phosphate is attached, on which carbon atom the phosphate is attached. Here the phosphate was attached on the 6th carbon atom. The second phosphate that is attached from the ATP. So ATP gives 1 phosphate, so it becomes ADP. This phosphate goes and attaches to the first carbon atom. So initially it was attached on 6th. The newly coming phosphate attaches to the first carbon atom. So there are 2 phosphate groups. Hence the name diphosphate. So fructose 6-phosphate becomes fructose 1,6 diphosphate in the presence of an enzyme phosphofructokinase. Now what happens is all these are 6 carbon compounds. Even this is a 6 carbon compound. It gets cleaved into 2-3 carbon compounds. That means it gets cleaved into 2 compounds. Both the compounds are 3 carbon. If 6 divided by 2, simple division, we get 3. So this is also 3 carbon compound. This is also 3 carbon compound. So it's an enzyme called as aldolase. Fructose 1,6 diphosphate, which is a 6 carbon compound, is cleaved into 3-phosphoglyceraldehyde. Remember my words. 3-phosphoglyceraldehyde and DHAP, that is dihydrogen acetone phosphate or dihydroxyacetone phosphate. So it gets converted into 3-PGAA. We call it as this 3-phosphoglyceraldehyde and dihydroxyacetone phosphate, which both are 3 carbon compound. These both are reversible reactions. In chemistry, we would have studied reversible. These can be interconverted. These are also isomers. Hence, the name comes as phosphotriose. Here, all we used exose because it is 6 carbon compound. It is a 3 carbon compound, so we are using triose here. And here we call them as phosphotriose isomerase. Isomerase because it is interconversion of isomers. This can be converted into this and this can be converted into this. This is a reversible reaction. So phosphotriose isomerase. Now onwards, whatever steps that is occurring over here, same steps will be occurring here. So hence the reason we have just put a dotted line over here. Same reaction, same enzymes utilized. Whatever occurs over here, same reaction occurs over here also. So 3-phosphoglyceraldehyde is converted into 1,3 phosphoglyceric acid. Aldehyde is being reduced into glyceric acid. So whenever aldehydes are reduced, they give rise to carboxylic acid. Hence phosphoglyceraldehyde is becoming phosphoglyceric acid. And if you see over here, there is the conversion, dehydrogenation is nothing but reduction. There is a removal of hydrogen atom also taking place over here. Hence the enzyme used is phosphoglyceraldehyde. The substrate is nothing but, see, whenever you are writing enzymes, there is an nomenclature for enzymes. You have to write the substrate molecule and what reaction it is occurring. These two names should be there. So here the name of an enzyme is phosphoglyceraldehyde dehydrogenase. Phosphoglyceraldehyde is the substrate and dehydrogenase is the reaction that is occurring. It is cleaving the hydrogen. It is removing the hydrogen. D means remove. Hydrogenation means it is removing the hydrogen. Hence, from where it is removing? From phosphoglyceraldehyde. Hence, the enzyme name is phosphoglyceraldehyde dehydrogenase. With that enzyme, 3-phosphoglyceraldehyde is becoming 1,3 phosphoglyceric acid. Simultaneously, the phosphate group is also added. From NADP, the phosphate group is also added and hydrogen is also removed. So NADP becomes NADH2. P is removed. Phosphate is added over there, right? So it becomes NADH2. Next, what happens? 1,3 phosphoglyceric acid. One of the phosphate group is removed. So 1 and 3 it refers to the position where the phosphate group is attached on the carbon atom. It is attached on the first carbon atom and on the third carbon atom. So from the first carbon atom, one phosphate group is removed. So here whatever ATP was giving rise to ADP, here ADP will become ATP. So ADP is adenosine diphosphate. One phosphate group is added to here. It becomes triphosphate. That is nothing but adenosine triphosphate. So 1,3 phosphoglyceric acid becomes 3-phosphoglyceric acid with the liberation of ATP molecule in the presence of phosphoglyceric acid kinase. As I mentioned, wherever ATP comes, you have to write the enzyme kinase and the substrate is phosphoglyceric acid. Hence, phosphoglyceric acid kinase is the enzyme involved. And for all the reactions over here, magnesium is a cofactor without which the enzyme won't be activated. So for everywhere, blindly you can just write Mg2 plus ion, which is nothing but cofactor, metal ions these are. Next, this 3-phosphoglyceric acid gets converted to 2-phosphoglyceric acid. Now the phosphate group that was attached to the third carbon atom is replaced to second carbon atom. So in the presence of an enzyme, phosphoglyceromutase. Phosphoglycero is the substrate mutase. So the movement of ADP molecule, phosphate molecule takes place over here. So 3-phosphoglyceric acid is getting converted to 2-phosphoglyceric acid in the presence of phosphoglyceromutase. Mg is acting as a cofactor. 2-phosphoglyceric acid becomes phosphoenol pyruvate. It is reducing. That is in the presence of enolase. Enolase is an enzyme. It becomes in the presence of magnesium ion acting as cofactor. 2-phosphoglyceric acid, that is the last product that was obtained over here. 2-phosphoglyceric acid getting converted into phosphoenol pyruvate. The name enol is the enolase from the enzyme, so it is easy to remember. It gets converted into phosphoenol pyruvate. Now the last step, phosphoenol pyruvate, will be furthermore reduced to pyruvic acid, which is a 3-carbon compound carboxylic acid. It is a 3-carbon compound carboxylic acid in the presence of an enzyme pyruvate kinase. Why the name pyruvate? Because the substrate over here is phosphoenol pyruvate. Pyruvate is a substrate. And kinase because the ADP is getting converted into ATP. Phosphoenol pyruvate. There is one phosphate group there. So same phosphate group, whatever we had studied over there, that phosphate group is removed. So ADP takes that phosphate molecule and it becomes ATP and it forms pyruvic acid. Same reaction occurs over here also. So one more pyruvic acid also is formed over here. So one pyruvic acid from this side and one pyruvic acid from this side. So you get 2 pyruvic acid. But the initial was only 1 glucose. So one glucose molecule is broken down or it is degraded into 2 pyruvic acid. What is the net gain or what is the significance if you see over here? Here in one product you can find NADH. Similarly here also one more NADH you'll find. So you will find 2 NADH molecule. 2 NADH2 molecule you will find. Here one ATP molecule is found. Similarly here one ATP molecule is found. So in one path or in one chain 2 ATP molecules are found. Similarly in this chain another 2 ATP molecules are found. Totally 4 ATP molecules and 2 NADH2 molecules are generated over here. NADH2 in the last process of respiration, it undergoes oxidative phosphorylation or terminal oxidation and it gets converted into ATP molecule. This NADH2 gets converted into ATP molecule. So one NADH2, 1 NADH2 is equals to 3 ATP. 1 NADH2 is equals to 3 ATP. So we have 2 NADH2. By simple multiplication, 2 into 3, we get 6 ATP. This is a last process. This won't happen here. NADH2 will remain like that. As soon as NADH2 formed, it moves on to the electron transport system where the terminal oxidation occurs and all the NADH will be converted into ATP. Therefore, 6 ATP molecules and 4 ATP molecules, 10 ATP molecules is generated. Out of this 10 ATP molecules, here one ATP is utilized and here one ATP is utilized. So 2 ATP molecules are utilized. 10 minus 2, 8. Therefore, 8 molecules of ATP is the net gain of this glycolysis. So this glycolysis is a very important question if you are entering into any examination. It can be asked for a 5 marker or 10 marker. So the enzymes are very important, and also along with the enzymes, the reactions are very important, and the net gain is very important. This is the significance. So just one molecule of glucose, it gives rise to 8 molecules of ATP. So this, what happens to this pyruvic acid? 2 molecules of pyruvic acid is formed. This pyruvic acid, it enters the next phase called as carboxylic acid cycle, TCA cycle, or citric acid cycle, or it is also called as Krebs cycle. Before that, the pyruvic acid, prior to that, the pyruvic acid is converted to acetyl coenzyme A, then it enters into Krebs cycle. So that will be dealt in a separate video. So this is the glycolysis, which is the first step in respiration, which is very important step. It is also called as common respiratory pathway. It is common for all types of respiration, and it occurs in cytoplasm of the cell. So this is the simple. It is very easy. If you just remember the enzymes, you can deduce the enzyme from the names. If you just remember the step-by-step reaction, the conversions, the enzymes also can be written. So I hope this video was very useful and I made it simple and clear for you. Thank you for watching this video. Please do like my video, subscribe to my channel, and please post your comments or suggestions so that I can improve on topics whichever you want. You can post it as a comments. I'll try to do that topic and post it. Thank you.